morning, Group A students. We're going to go ahead and start today by looking at our bell work. Remember, bell work is optional, but it's just something that's good to use for review because you could see the question on a test or a quiz. So I would recommend doing the problem along with me. So it says, find the x and y intercepts of the function. Recall from yesterday, we learned how to find an x-intercept. You set the y equal to 0. Remember, this q of x represents y. Okay, it's function notation. That's exactly what I'm going to do. Plug in y is 0 and solve for what x has to be. Add 8 to both sides so that we get 8 equals x squared. How you undo something that's squared is you take the square root. Anytime you take the square root, you always get the positive and the negative version out of whatever you took the square root of. So we get plus or minus root 8. You could simplify this if you want to 2 root 2 plus or minus 2 root 2, or you can just leave it root 8. So I'm going to put my intercepts, plus or minus root 8, comma 0. That's my x-intercept because I solved for x. Okay, so that's how we find an x-intercept. To find a y-intercept, we're going to do the opposite. We're going to set x equal to 0 and plug that in. So y equals 0 squared minus 8. Plug it in place of the x there. Then solve. 0 squared is 0 minus 8, and 0 minus 8 is negative 8. So our intercept, remember you have to write these as ordered pairs because they're actual points. 0 was the x that I plugged in, and y was negative 8 that I just found. So 0, negative 8 is our y-intercept. Today we're going to go ahead and continue talking about Chapter 1, Section 1.3b. This is the second half of 1.3. We did the first half yesterday. Today we're going to finish it up with 1.3b. We're going to learn about domain and range. Domain and range we studied a little bit yesterday, but now we're going to have to analyze it in terms of a graph. So as you look at the example that I have on the screen, average college tuition since 1980, you could describe the domain and the range in terms of what the graph represents. And the domain and range helps us to analyze the data that is on the graph. So let's go ahead and look at our notes. Remember the notes, they are on Canvas. You can follow along with me or you can take your own notes. First, let's review from yesterday. What is domain and range? Remember domain yesterday is the x value and it is the input. So it's what goes into the function. Range is the y value, and it's called the output. It's what comes out of the function after you plug the input in. Something else for us to think about, x values run along the x-axis, and the x-axis runs left to right. Okay, that's something to remember. Range is the y values, and the y-axis runs up and down. That's going to be important for what we're doing today. So domain is left to right, range is up and down. We can write the domain and range of a continuous graph. Continuous means that it has no stopping points, using what's known as interval notation. Interval notation. In pink here on the screen, those are our different symbols. If we have parentheses, it's because the point that I'm talking about for domain and range is not included, so it doesn't exist on the graph. And it will be represented by an open dot. So open dots mean that it's not included. It's called a hole in the graph. Included is if it has brackets, it's going to be using a closed dot, and that means that it is included. So an open hole is not included, closed hole is included. And then a U represents a union of two sets. So we're going to use these three symbols today to analyze the domain and range of different graphs. Let's go and start with our first example. State the domain and range of the function. So domain, recall domain is the x values and it goes left to right. Range are the y values and they go up and down because that's the way the y and x-axis face. So as we look at domain, I'm going to look from the left to the right, because that's the way the x values go. So as I look to the left of my graph, it's going to the left, to the left, to the left, and as it keeps going to the left, it's going to the negative x values. So it's just going to keep going on down. Notice it's keep going to the left to the negative x values. Remember, we're looking at the left side. And the left side's negative, so it's going from negative infinity. Infinity, because it's got an arrow, I know it keeps going on down. And then as I go to the right side of my graph, so now to get the other point, I'm going to go to the right side. So as I move to the right side, my graph has another arrow, and it's going on and on forever in the right direction to the positive x values. So this goes to positive infinity. So domain, you look left to right. This graph keeps going to the left. So it goes from negative infinity and it goes off to the right. Even though it goes down, that doesn't matter because we're just looking at the right side. So it keeps going off to the positive x values. Let's try the range. The range I'm going to do in green. So range, we look bottom to top. So as I look at my y-axis right here, my graph keeps going on down because of these arrows. It's still going down, right? So it's still going to negative infinity. It's just going to go down forever. And then as I go up, it's still going up, 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 up. And then it stops right here. It's at highest point. That highest point is at 3. So that's where my range stops, at 3. Because it's a closed dot, we're going to use a bracket. Okay? So domain goes left to right because it goes forever to the left, forever to the right because of the arrows. It's negative infinity to positive infinity. You can also see this written as all real numbers. Sometimes you'll hear it both ways. All real numbers. Either way works. Then the range, bottom to top, keeps going on down, so it goes to negative infinity, comes up to 3, that's its highest point, and it's closed, so it's a bracket. Let's try another one. So looking again at domain and range. Domain, remember we look left to right. It's our x values. So as I look at my graph, how far left does it go? Well, it goes forever to the left because of the arrow, so it goes from negative infinity. Then as I go to the right side of my graph and I move to the right, it's got another arrow, so it's going to keep going to the right, which means it goes to positive infinity. Infinities also use parentheses because we can't reach it. I can never go to infinity. I can just use parentheses because it's not included. Next one, let's do range. Range, we go from bottom to top. So how far low does my graph go? Goes all the way down to negative infinity. And then it comes all the way as I track it going back up. It keeps going on up to positive infinity. Okay, so that one has a domain and range that are the same, which can happen sometimes. It won't always happen, as we saw with the first example. Let's try some more of these domain and range type problems. On example C, we have another graph. State the domain and range of the function. So first I'm going to look at domain. Doesn't really matter which one you look for first, but I always like to look for domain. Remember, domain goes from left to right. And I'm going to put some arrows on the end of my graph, so that way we know it's continuous. Domain. So as I look at my blue graph, how far left does it go? Well, notice I'm still going to the left, so it goes from negative infinity with parentheses. And then how far right does my graph go? Well, it comes all the way up to here at, looks like 2. Right here is what's known as a hole. So since I have a hole at 2, I'm going to stop my graph at 2. Remember we said open dots use parentheses because they're like holes in the dirt, right? A hole in the dirt is where nothing, there's just air right there. That's kind of what a graph is like when it has a hole. It's a spot where the graph, you follow it and then you jump over the hole and then you can continue on with your line. So negative infinity to 2, because that's an open hole, that's where we stop, so I use parentheses. But then after I jump over the hole, my graph goes from 2, it goes all the way to the right, so it goes to positive infinity. Because I had a break in a graph because of the hole, I'm going to use that union symbol to join the two pieces together. So domain looks from left to right. Okay. The reason I chose 2 is because this is the x value of 2 where that hole occurs. Let's go do range. Range, remember, you look from bottom to top. So as I look along the y-axis, how far down does my graph go? Well, it keeps going down, 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 down. Because it's got an arrow, it's going to keep going on down. So it goes from negative infinity. Then as I keep tracing my line, I'm going up, 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 and then I hit the hole. The hole has a y value of 3. Now I'm going to use parentheses because it's a hole. It's where the graph stops. But the graph continues after the hole. So we pick back up at 3. And it keeps going on up to infinity and beyond. Because we've got 2 pieces, we're going to join them together with a U, the union. Let's try example D. Gives us another graph. We're going to find domain and range of that one. Domain, what direction do we look? Left to right. So I'm going to look farthest to the left of my graph, goes off to the left at negative infinity. Then as I move from the left to the right, my graph keeps going and it stops at negative 3, it looks like. But if you notice, here's a closed dot and here's an open dot. Closed and open dots, even though they're at separate points in the graph, right? The open dot's way up here, the closed dot's way down there. It's still connected because remember, we're only looking at the x-axis. So I know that probably sounds strange. Because we're only looking at this x value, negative 3, it's got an open dot up there, a closed dot down there. Closed always overtakes an open dot. Okay, so just remember that. Closed overtakes the open, so the graph continues. So I'm going to keep going to the right. Then I stop again because there's an open dot there. But notice there's a closed dot here. Since they're on the same x value, closed trumps the open. So I'm going to keep going, ride my graph on over to the right where I find an arrow. So it goes from negative infinity to positive infinity. That is my domain. Even though I had those breaks in the graph, the x values were the same at the open and closed dots. That's why I don't need to use a union symbol. Let's go find the range. Range, which direction do we look? Bottom to top. So along the y-axis, how far down does my graph go? Well, it looks like it starts at negative 2. And it's pretty continuous for a while at negative 2. So I'm going to start at negative 2. Then I notice that it doesn't come up here again until right here. So I've got a break between negative 2 and 0. I'm going to use set bars to say it's negative 2 because it's just one point. It's not a whole set of points. It's just negative 2. Union. Pick back up at 0 because that's a closed dot. I'm going to use a bracket. And then I keep going up on my graph. Notice that as I keep going up, 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 there's an arrow, so it goes off to infinity, where we use parentheses. Okay, that's how you would do domain and range for graphs. Okay, now we're going to try some where I don't give you the graph, but we're going to graph it using our graphing calculators. We're going to write the domain and range in interval notation of each function. Again, you can use a graphing calculator. I posted a link to Desmo's graphing calculator on Canvas under today's video lesson, so you can click on that, and it's a great website that has graphing calculator on it. Or I'm going to also stop periodically and show you how to type it in your actual graphing calculator if you have one, to follow along with me. So let's look at example E. It says f of x equals x minus 4 squared plus 5. So when we're finding domain, we're really asking ourselves where the bottom of a fraction is 0. Where the bottom is 0, right? We learned that the first week of school, that a fraction is undefined where the bottom equals 0. That's what we're asking ourselves with domain. Let's go ahead and type this one in the calculator. What you're going to do is first turn your calculator on, then go to the y equals button. And then it's going to pull up a bunch of y1, y2, y3. Those are just different graphs. I'm going to stick with y1. We're going to type in our first function, parenthesis, x minus 4 squared plus 5. That's our function, so I'm going to hit this graph key in the upper right-hand corner, and then we get a picture of our graph. And we're going to use that to analyze domain and range of our function. You can see here that this low point is at 1, 2, 3, 4, 5. So that's a low point. That's something to point out. So our domain, since I've got arrows, it goes from negative infinity, because it keeps going off to the left, to positive infinity, because it keeps going off to the right. Again, we use parentheses because we can't reach infinity. Then our range. Range, we look from bottom to top. So range, how far low does it go? Well, it stops right here. If you look at your calculator, that's at the 0.5. Since it's included, I'm going to use a bracket. And then it keeps going on up to infinity with a parenthesis. So that's our first answer on E. Let's go ahead and try F. F is negative 2x squared plus 3. Again, let's graph that in the calculator. I'm going to clear the previous one out under that y equals button and type in my next one. Negative 2x raised to the second power, then arrow over, plus 3, and hit the graph key. That pulls up a nice graph so you can see where the high point is up here right at 3. Here's a rough sketch of what your graph should look like. It's an upside down U. Let's go find domain. Let's go find range. Domain, remember we look from the left to the right. How far left does this go? Even though it's going down, it's still going to the left. So it goes from negative infinity. And then as I look from the left side of my graph to the right side, it's going still to the right, so it's going to positive infinity. That's our domain. Our range. Range, you look from bottom to top, just like the y-axis runs. How far low does it go? It goes from negative infinity because it keeps going on down. How far high does it go? Stops right here at that point, which is 3. Because it's included, it's touching it, I'm going to use a bracket.